Now we discuss free fall. Free fall is when an object moves only under the influence of gravity. That is, gravity is the only thing acting upon it. So in other words, it's basically just an object falling. So how do we apply our equations of motion to an object in free fall? Well, first of all, the equations of motion have delta x. That is, they're written for horizontal motion, and we want vertical motion. So that's easy enough to solve. We just take delta x and make it delta y. So our equations of motion would look like delta y equals v0t plus 1/2 at squared, and v equals v0 plus at, and v squared equals v0 squared plus 2a delta y. Alright, so that's not really 6 equations of motion, it's just 3 equations of motion, but sometimes the delta x is a delta y if you want to use it in the y direction. Alright, the next thing is, what is the acceleration? Well, the acceleration due to gravity is the letter g, which is 9.8 meters per second squared. So any object that is falling accelerates with this acceleration, 9.8 meters per second squared going downward. So when we apply our equations of motion, we're going to put the acceleration is negative g, or acceleration is just negative 9.8. Now it's important to remember, g is a positive number. G is just the number 9.8. It's independent of what coordinate system you're using. So we say the acceleration due to gravity is this amount. But when we apply it to a coordinate system where positive x is to the right and positive y is up, in order to say that the acceleration is down, we have to say that the acceleration is negative 9.8. So now we have these equations of motion, but for the case of free fall, we state that acceleration is negative 9.8 meters per second squared. I should also mention that it is theoretically possible to make a coordinate system where down is positive and then the acceleration will be positive 9.8. But we're not going to do that. For this course, we assume that positive y is up. So in all cases, your acceleration will be negative 9.8. Alright, let's see what negative acceleration means and how it affects the velocity. So let's look at this case where we've thrown something from the top of the building straight upward and it goes up and comes back down to the ground. So what is the velocity going to look like? So let's say our initial velocity looks like that, and I'm going to draw the velocity along here, and it's going to get smaller and smaller. So negative acceleration is going to make this positive velocity get smaller and smaller and smaller. When it gets to the top, it's 0, and then it's going to start small again, going down, and what happens is negative acceleration is going to make this negative velocity more negative. And it gets bigger and bigger and bigger in magnitude, but more and more and more negative. So that's the concept of negative acceleration. In both cases, going up, the acceleration is negative, and going down, the acceleration is negative. When it's going up, the negative acceleration takes away from this positive number and makes it smaller. When it's going down, it's negative. So the negative acceleration is going to make that negative velocity more negative. So the magnitude of the velocity is going to get bigger and bigger and bigger. So now let's do some examples. If you drop an object from rest and it takes 5.5 seconds to reach the ground, how far above the ground are you? So let's look at the quantities in here. From rest means that it started from rest. That's going to be our v0. Our initial velocity is 0. 5.5 seconds is obviously a time. And then how far above the ground are you? So how far, that's going to be a distance. And since we're in the vertical direction, then that will be delta y. And of course, since it's free fall, acceleration will be negative 9.8. So we have the initial velocity, the time, and the acceleration, and we want to find delta y. Well, our first equation would work perfectly for that. So we can just say delta y equals v0t plus 1/2 at squared. So 0 plus 1/2 times negative 9.8 times 5.5 squared. And we get negative 148 meters. So why is it negative? Well, delta y is final minus initial. It's basically what the displacement is in the y direction. Well, since it went down, then the displacement should be negative. So that accounts for the negative sign there. So really, to answer the question, how far above the ground are you? The answer would be 148 meters. And that's it. For our next example, an object is thrown directly upward at a speed of 24 meters per second from the top of a building that is 14 meters high. So the question is, how long does it take to reach the ground? And what is the maximum height above ground that it reaches? And then finally, what is the velocity at the bottom? That is when it reaches the ground. So let's look at the motion that it's going to do. It's going to go up, and then it's going to come directly back down. So question A is asking, what is the total time? Question B is asking, what is the maximum height above ground? That is, how high is this point above ground? And question C is asking, what is the velocity at the bottom? So you might think, well, the velocity at the bottom is 0 because it stops. We're talking about the velocity just as it's hitting the ground. So the equations of motion tell you what happens while it's in the air. In terms of the collision with the ground, that's a separate problem. So when we refer to the velocity at the bottom or the velocity as it's hitting the ground, it's the instant before it hits the ground. All right, so let's tackle these questions one by one. How long does it take to reach the ground? How much time? So what we want is the time. We're looking for the time. We have the initial velocity here. We have the height here. We'll just call it h. And we want to know how long it takes to reach the ground. Well, we need something with time. So if you look at this equation, this doesn't have the height anywhere in it. So let's start with this equation. Turns out this is going to be the one to use. So delta y equals v0t plus 1/2 at squared. All right, what is our delta y? Our delta y is the displacement from here to the bottom. So it starts here and finishes here, so the displacement is negative 14 meters. If the displacement were positive 14, that means that it would finish somewhere above where it started. But when it finishes below where it started, then the displacement is negative. So delta y is negative 14. Now what's our initial velocity? v0, we're given that, 24 meters per second. 24, t, we don't know. 1/2, acceleration is negative 9.8. Now, some people think that when it's going up, it has a different acceleration than when it's going down. Like some people say, well, it's going up, shouldn't it be positive? Well, the acceleration is always negative 9.8. Whether it's going up, whether it's going down, no matter what, the acceleration is negative 9.8. So how does that work? When it's going up, the velocity gets slower and slower and slower and slower and slower. Well, that's a negative acceleration that's going to cause that slowing down until it reaches the top. And then when it goes down from the top, it's going to be a negative velocity. It's going to get more and more and more and more negative. So a negative acceleration will make a negative velocity more negative. So in any case, the acceleration is negative 9.8. You don't even have to think about it. Just plug in negative 9.8 for the acceleration and you'll be fine. All right, now to solve this is a quadratic equation. So we have to put it in the correct form to solve it using the quadratic formula. So let's put everything to the left side. So this is going to be 4.9t squared minus 24t minus 14 equals 0. For the quadratic formula, this will be a, negative 24 will be b, and negative 14 will be c. To solve it, we get t equals negative b, so that's 24, plus or minus the square root of b squared, so that's 24 squared, minus 4, a is 4.9, and c is negative 14. So that's going to be 14 here, and that'll make the negative a positive. And all over 2a, so 2 times 4.9 is 9.8. So we have to calculate both cases with the positive sign and the minus sign and see what we get. So we get 5.42 seconds or negative 0.527 seconds. So which one do we pick? Generally, we pick the positive one. But let's look at each and see if there's a physical significance to each number. Okay, 5.42 seconds is a positive number, so that's the time that it would take to go from here down to the bottom. Negative 0.527 seconds is really time going backwards. It solves this equation because it's the time that it would take if you went backwards to go from here back down to here. So given that the velocity is 24 meters per second here and the acceleration is negative 9.8, if we move time backwards and went down to the bottom, it would take us 0.527 seconds going backwards. But of course we reject that one because time doesn't flow backwards and we're not dealing with that. So this is the answer, 5.42 seconds. Now here's one question people often have. If we're calculating the time of flight, that is, if we know the height of the building and we know the initial velocity and we want to know how long it takes to get from here all the way to here, we can see that the path goes up all the way to the top and to the bottom. But when we consider our initial and final points, this is initial and this is final. So the question is, does that ignore the path all the way up here and back? You know, maybe it's just sort of doing this. Okay, the answer is that the mathematics does take into account the whole path. We're saying initial and final for this motion. This motion is included in these equations of motion. An object that starts from here and doesn't go up, say it drops from rest, it's going to have a different equation because its initial velocity will be 0. Or something that's thrown downward from here. So again, it's not going up, it just goes straight down. Well, that initial velocity will be negative. So each case has its own specific equation. The case of an object having a positive velocity so that it goes all the way up and back down, it's correctly described by the equations of motion when we consider this to be initial and this to be final. Now, for part B, what is the maximum height above the ground? For maximum height above the ground, you kind of have to know a trick here. The maximum height, so you're at the top. What's special about the top? At the top, the velocity is 0. We have a positive velocity going up and a negative velocity going down. When it reaches the top, it goes from positive to negative, so it just goes through 0 for a little instant. So we use that as a technique for getting the maximum height. So how do we do that? Well, we're going from here to here. So now notice that on part A, this was our initial, right here, initial, and then this was our final down here. For part B, we're going to consider just the motion from here to here. So that will be our initial, and the top will be our final. So depending on what you want to solve, you may have your initial and final in different places for the same problem. Since we don't have a time for part B, and we're not trying to find the time, it's convenient to use this last equation, which does not have time in it. So we can say v squared equals v0 squared plus 2a delta y. So now at the top, v, which is our final v, is 0. Initial velocity is 24. 2a is negative 9.8. And delta y is unknown. What's delta y? Delta y is not the displacement of the whole trip, the whole flight, from beginning to end. Because we're saying that this is our initial and this is our final. So delta y, in this case, is this distance right here, from initial to final. It's from the top of the building to the maximum height. So that's what we're going to solve for. So what we get is 29.4 meters. Now that is the displacement from where it started to the top. Does that answer the question? It asks for the maximum height above ground. So we need to add the height of the building to get the total height above ground. So this is the height that we want. This is the height above ground. So we can say maximum height above ground equals 29.4 plus 14, which is 43.4 meters. So that's the answer there. Now for part C, what is the velocity at the bottom? So now our initial is going to be here, and our final is going to be here. So we're considering the whole flight. It starts here and finishes here. Now the velocity at the bottom is v, so we want an equation with v final, or v. So we could use this one because we have the initial velocity, we have the acceleration, and the time is the total time for the whole trip. So that should give us what we need. v equals v0 plus at. So 24 plus negative 9.8 times time, the total time is 5.42. We found that out in part A. And this gives us negative 29.2 meters per second. All right, it's negative because the velocity is going down. Now there's another way we could solve this. We could use this equation too, because we want the final velocity, we have the initial velocity, we have the acceleration, and we have delta y, which is the displacement from the beginning to the end. So let's do that. v squared equals v0 squared plus 2a delta y. So v squared equals 24 squared plus 2 times negative 9.8 times negative 14. So v is the square root of all that. There. What do we get? If you calculate this, we get 29.2 meters per second. So why is that different from this? Well, we made a mistake. So when I took the square root of both sides to get v, when you take the square root, it's really plus or minus. For example, what's the square root of 25? It's not 5, it's 5 or negative 5, because negative 5 squared is also 25. So when you take the square root, don't forget the possibility of the negative answer as well. So really it should be plus or minus 29.2, and we choose the minus because the velocity is going down. So you could make a mistake by using this method because you might forget about the negative one. So in the end, the velocity is going down, so the answer is negative 29.2. So now here are some examples for you to do. The first one is, if you drop an object from rest and it takes 4.5 seconds to fall to the ground, how far above the ground are you? And the answer is 99.2 meters. The second one is, you launch an object from the top of a building, the building is 20 meters high, and the initial velocity is 14 meters per second. So the questions are, how long does it take to reach to the ground? And the answer is 3.9 seconds. What is the maximum height above ground? That's 30 meters. And what is the velocity at the bottom, which is negative 24.2 meters per second. And here are two more. An object is thrown downward at a speed of 8 meters per second from a height of 15 meters. How long does it take to reach the ground? So the only thing different about this one is that it's thrown downward. So you have to be careful that the initial velocity is negative. So the speed is 8 meters per second, but v initial is negative 8 meters per second. Other than that, it's very much like the first problem. And if you want a challenge, here's number 4. It's just a little different than all the other ones. You're solving for something different, but it uses the same equations. So an object is launched from the ground, from down here, it lands on the roof of a building. So it launches from the ground, it goes up and lands on the roof. It reaches a maximum height of 3 meters above the roof of the building. So that's 3 meters above the roof of the building, not above the ground. What is the initial velocity and what is the time of flight? So what the initial velocity we're looking for is down here, v0. And the time of flight is the time for the whole trip.